right, the focus of this reteaching is that students create two patterns using two different rules and then be able to compare terms from one pattern to the other. So by comparing terms, we could say like a multiplicative comparison. So like example 1 asks a multiplicative comparison. Pattern A, all the terms in pattern A is like what fraction of all the terms in pattern B, or it could be like an addition or subtraction comparison like example 2. All right, so with this reteach, the teacher models the exemplar. So you're going to do a think aloud for example 1 and example 2. The student's job is to copy down your exemplar, but also on their own complete the questions from the right pair share. Then you will ask students to pair and share their answers, and then finally we'll share out loud. But this is like the right pair share is giving the students like this clear listening or like thinking task that makes this reteaching more active rather than passive, right? So you switch into your like teacher like think aloud voice, so like vary your tone, right? As you read the first example. Which statement about the corresponding terms in both pattern A and pattern B is always true? Pattern A, 3, 6, 9, 12, 15, 18, and pattern B, 12, 24, 36, 48, 60, 72. It's going to be really hard for me to see like what the relationship is if I don't know the relationship between each term and the next term in pattern A, and if I don't know what the relationship is between this term in pattern B. So I'm going to write this into a table, and a table helps me see this more clearly. So I'm going to write A and B, and then all my terms for A, 3, 6, 9, 12, 15, 18, and all my terms for B. Oh, when I write it, I can see that with pattern A, I'm adding 3 times, or I'm adding 3 each time. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18. I'm going to go ahead and write this operation in. I'm going to do the same thing with pattern B. 12, 24, 36. Oh, I can see that I'm adding 12 each time. 12 plus 12 is 24, plus 12 is 36, and so on. So I'm writing these operations. Okay, this is asking me to compare the terms in A with the terms in B. So having it in this table is super helpful because I can see, well, 3 times 4 is 12. Let's see if that works for the next one. 6 times 4 is 24. Oh, 9 times 4 is 36. Oh, it seems to be working. 12 times 4 is 48. 15 times 4 is 60. 18 times 4 is 72. Interesting. So the terms in A are less than the terms in B. The terms in B are 4 times as great as the terms in A. Let's look at our answer choices. Each term in pattern A is 4 times the corresponding term in pattern B. Well, that's not true because A is smaller. A is it's 1/4. It's not 4 times as big. It's 1/4 of B. Let's look at the next one. Each term in pattern A is 1/4 times the corresponding term in pattern B. I think that's true. Let me do some scratch work over here just to make sure. If I were to say 1/4 of, let's say 12, do I get 3? 1/4 times 12. That gives me 12 over 4. That's 3. Oh, that seems to work. Let's do 1/4 of 24. Oh, that also seems to work. Let's do 1/4 times 36. Oh, that also seems to work. Great. So I think the answer choice B is my answer. Each term in pattern A is 4 less than the corresponding term in pattern B. Well, that's not true because if I subtract 12 minus 4, I don't get 3, so that can't be true. Each term in pattern A is 9 less than the corresponding term in pattern B. Let's see. 12 minus 9 is 3. Ooh, that's interesting. That works out. Let's make sure it works for every single term in pattern A and pattern B. 24 minus 9. Oh, that does not give me 6. 24 minus 9 does not give me 6, so I know that D can't be the right answer. That means my correct answer is B. One of the things that I did to show my work in this problem was that I created a table, and then I showed the operation between each term, and then I showed the operation between the terms. Answer A was trying to trick me. It said that each term in pattern A was 4 times the corresponding term in pattern B. That's actually not true because it's flipped. The term in pattern B is 4 times A. So I need to be very careful when I look at problems like this to make sure that I'm not getting tricked. Another thing that I did was show some scratch work over here so that I could make sure that my answer choice matched up with this math. Let's look at the next example. Jack and Trinity run around the track every day. On day 1, Jack ran 2 laps, and each day he added 2 additional laps. On day 1, Trinity ran 6 laps, and each day added 4 additional laps. How many more laps did Trinity run than Jack? Okay, when I see how many more, I think that I have to subtract. But before I can start to subtract, I have to figure out how many laps Trinity ran and how many laps Jack ran on day 6. So again, I'm going to make a table. Here I have Jack's laps and Trinity's laps, and then I want to make a table, a column that shows me the number of days. So on day 1, Jack ran 2 laps, and he's adding to each day. So 2, 4, 6, 8, 10, 12, and here are my days. So I can see on day 6 that Jack ran 12 laps, and then Trinity started with 6 laps, and then each day added 4. So plus 4, plus 4, plus 4, plus 4, 6, 10, 14, 18, 22, 26. I can see that Trinity ran 26 laps on day 6, and Jack ran 12. It's asking how many more, so that means I'm going to subtract 26 minus 12. Trinity ran 14 more laps. And then, so after you go over this, then have students do this right pair share. These are some answers that we could hear. We want to set up the table. We want to show the operation between the terms. We want to label all the columns in the table. This is the active thinking that kids are doing. Then once more, like before you transition to the independent practice, say what model or like what strategy did I use in both of these problems to show my thinking. The strategy that I used in both these problems was to create a table.